Thank you, everyone, and thank you for coming to our webinar today. And we will discuss mainly about the DFX know-how digitalization based on our 3D DFM DFA solution. And before I start, I'm here today. My name is Elizabeth, and I'm the senior technical consultant, and I'm here having this webinar together with my colleague David. He's also the senior technical expert of our team. And say hi to everybody, David.
Hello everyone, this is Stevie here. Very glad to meeting you guys here. Today we will talk about DFX know-how digitalization. If you guys have any questions about DFM, DFA, you can type your questions in the chatting board. We will check it later and we will talk about that. Thank you guys.
Yes,
Talk to you later.
yes. And I would like to introduce our company a little bit. We have been working in this industry for over 18 years, and we aim for the DFM/DFA solution, placement, programming, and also the printing stencil process, also for the testing and inspections, work instructions, and many more. We have over 20 MPI software products, and we have over 100 employees here in China, Shanghai. And if you guys have business travels in Shanghai, welcome to visit our office. And we have over 500 clients distributed in over 20 countries. And we have strategy partners with equipment providers like Fuji, Panasonic. And those 18 years, we only have one focus for the NPI solutions for electronic manufacturing. And here you can see this is our some of the solutions that we offer, including DFA, of course, and also the core SMT process know-how digitalization, which enables you to transfer the past experience of great stencil experience into the digitalized know-how database for your team to use in the future, and also our automated placement programming and the DFT testability strategy, visual aid work instruction, SMT, specialized CAM tool, very easy to use. And if you are interested in any of those solutions, just let us know and we could discuss further. And as we stated, our customer has distributed in worldwide and in different industries, including telecom network, clients like Nokia, ZTE, and Comascope, and for computer, Intel, NVIDIA, Dell, SanDisk, and also for electronics, consumer electronics, Vivo, Oppo, Xiaomi, and for automotive industry, Tesla, NIO, Johnson Controls, Bosch, Continental, they are all our clients. They are using our software to improve their process. And of course, the energy security medical providers like GE Healthcare, Edward Life Science, Intuitive, and many more. And also the EMS companies like Flex, Venture, Foxconn, Celestica, and many more, as you can see right here. And we are partners with ASM, Fuji, and Keysight, and they are our strategy partners. And like Keysight, there are a few sites worldwide that are using our test solution internally. So if you are interested in those, feel free to contact us. Our solution helps clients is not just what we state, but how our clients experience and what feedback they give back to us. And for like a venture, they have working with us using our solution since 2009. It has been a long time, and we are very grateful to have clients like them to improve their process, like manufacturing process, and providing great service and manufacturing great products to clients, which eventually may be used by everyone right here in this world. So many of you here today, I would like to ask, how long has your company been founded? So how many years of experience the engineers on your side has gained, but how do you achieve those experience or knowledge transformation? How to achieve the digitalization in this? So our 3D DFA DFM solution offers you a way to achieve the DFA know-how digitalization. We helps you to simulate assembled board and helps to run assembly analysis to predict the analysis problems that may occur during the manufacturing. We have over 1,200 checks for assembly analysis, 300 checks for fabrication analysis, and finally, we could offer you a DFMDFA report for you to demonstrate your advanced capability and also for your process team to use to communicate. Basically, the DFMDFA, our solution, what we do is to do these three big steps. The first would be simulate the PCB assembled board with our built-in 3D entity parts library. This one enables to virtualize the PCB board assembly process, and then we analyze PCBA with know-how rules. Those can predict the problem of design prototyping and during the mass production and post-sale stage issues that may occur. And then finally, it offers you the unique 3D DFM DFA report for you to review and for your team to communicate. Our solution helps you to build your own DFX knowledge base through the know-how digitalization. We offer 1,500 initial rules for you to use, including design, fabrication, and assembly analysis rules. And those rules are very flexible to edit and to configure. That is what we offer for you to transfer your know-how and into those rules. And also we make continuous improvement to our solution. We averagely add 50 rules each year because as we all know, we are facing challenges each year, each day, and each year. So we are developing together with the clients to facing and to resolve challenges. And also we support customized like a rule development for if you have special requirements. So that's our commitment to you. We have a strong team behind us. We have 50 employees in our R&D team. So that's our confidence to guarantee our solution and our services offered to our clients. And our clients using our solution, for example, there's a venture group immigrate our solution and they developed 30 rules in 4 months to meet continuous improvement expectations from their top client. They using our solution strengthen their capability and giving confidence in their own client and offer better service to them. With our 3D DFM, we have won the IPC Award in 2019. In 2019, there's only 5 winners for this award worldwide, and we are very honored to receive this award. And as you can see on the right, the IPC president and CEO, they visited our booth and took picture with my boss Howard in the middle. And the reason why 3D DFM DFA solution is so important is that a 3D DFM DFA solution enables you to review the issue that may happen in a very clear way. For example, on the picture on the left, if you review this one, you may not get what this issue might be, but on the right, if you review it, the issue is very much more direct and clear for you to present. This one may have the suitability issue. So when you get analysis a result with a 3D picture attached, it will be much more easier to read the report. And as you can see, our solution offers a virtualized board for you to review to find the difficulty and find the defects. When you DFMDFA solution, we support ECAD, Gerber, and BOM data sources. For ECAD, there are over 20 kinds of ECAD supports that ECAD format that we support, including Altium, Cadence, Mentor, Zukin, IPC 2581, and ODB++. And also we support BOM validation as well. We achieve PCB assembly virtualization through permanent local 3D package library. The software comes with a local library with 200K components modules for free. And we offer the very convenient tools for you to create new components. So you don't have to worry about in chance there are components cannot be found. You can definitely use our tool to build one very quick and easily. Component library, each one are created based on the datasheet of those components. So this allows you to virtualize the PCBA very accurately. And as you can see, the 1,500 checking rules, including fabrication and assemblies, are initial rules inside this software. And we support IPC guidelines and listed, as you can see, IPC 7351 and IPC 7095, and we are committed to develop new rules each year, as mentioned. The rules are very easy to configure and editing, and our technical expert, David, will show you during the demonstration of the software, and you can understand how easy it is. And finally, we will offer you a 3D report, very unique, very easy to read, and it helps the communication for you with your clients. I would like to show you some sample DFMDFA issues. For 3-level check-ins, the first level will be the design, omission, or mistake prototyping blocks. The level 2 will be the mass production issues. And the third level will be the product reliability risks. For example, for SMD package mismatch, wrong material or wrong footprint design. For example, for this one, if the footprint doesn't match it, we can catch it during the DFMDFA analysis, so it won't cause problems during the manufacturing stage. And also the mass production issue that you can predict, for example, the chip part too close to the connector, it will cause difficulty for rework in the later stage if there's anything happen, need rework. And the other would be the product reliability risk. For example, for this one, this pin doesn't have the thermal pad design. So there will be a risk for cold solder or poor solderability in the manufacturing stage. We would like you to use the solution, predict those kind of issues in the early stage and save time in the most extent. The other advantage of our solution is that our solution is very easy to use. Learning time for you is very short. Maybe some other industrial solutions, they are very powerful, and at the same time, they are very complicated. You will need invest a lot of time in learning and using the tool. Our solution is very user friendly, and there will be flow charts for you to follow step by step to get the final report. And generally, there are many features that allows you to learn it very quickly. There are other features like our solution integrate to EDA tools with Cadence and Altium. If we found the DFMDFA issues in our software after we run the checks, you can interact with your Altium or Cadence to make a modification very fast and easily. It helps you to work more effectively, so you don't have to do a lot of report files and save more time. And another one is that we can help our assembled board can be used for product level analysis. it supports UG, Creo, SolidWorks. It supported in those software as well. Very easy for you to do the later stage analysis. So in general, our DFM DFA solution gives you the PCBA virtualization and with the know-how digitalization, it helps you to build your own library of know-how digitalization and reuse them in the future. And if any of you have questions right now, or you have met challenges in other aspects of during the MPI process, feel free to contact us and communicate and share any challenge with us to our email address business@valueinfo.com or techexpert@valueinfo.com. And the next will be my colleague David doing the software demonstration. And after that, there will be a Q&A session. If you have questions during the demonstration, feel free to type down your questions in the chat board. We will answer them after the demonstration finished. Okay, thank you. So David, I'll give it to you from here.
All right. Thank you, Elizabeth. First, I need to say thank you, everyone. Welcome to our webinar. Now I'm going to show our software. Before I show our software, I'd like to give you an introduction of the mechanism of our software. Here we can see it is a DFA mechanism of our software. Mainly, we can separate them with three parts. The first part, that is data import. We will import your PCB data to the software and also BOM file. Then we will do virtually assemble your board. We can see this is 3 board. While we are doing this step, we will grab 3D components from our component library. And also in this step, we will check the component mismatch with the pad. So during this step, we will find the very important issue. You can report this to your R&D. And then we will run the knowledge base, and you will see there are many rules there. And we will run the rules and give you a 3D report. Now let's go through the software. As I mentioned just now, the first step, we will import PCB data. I'd like to show you our software supports many kinds of data source, such as Cadence BRD and Cadence VAL, and also Ultimate Designer, Zuken, IPC 2581, ODB++. You don't have to select, the software will recognize the data automatically. Now you can see the entire interface of our software. Just as Elizabeth mentioned, our software is very friendly use. So you can see here is a flowchart. Just follow up this flowchart and do it one by one. You will never forget what is the next step. And then we do BOM import. You see, here are 4 conditions for BOM self-checking. If your BOM has such kind of problems, duplicated PN or quantity mismatch, and then the software will report. And also we will set a template, you see, because some EMS company, they received many BOM format. So if we set a BOM template, the software can read the BOM automatically. Okay, now we see my BOM has this problem. The quantity is 3, but the PN is only 2. So that's a problem. We will check the BOM. We do next. This is BOM and CAD verification report. just focus on this part. That means some parts some parts in your BOM, but not in CAD. That means this component you need to assemble on your board, but on your board there is no any location for this part. So that's a problem. Check with your CAD file or BOM. There's something wrong with that. And now we will do the second part, PCBA virtual assembly. Before we do that, I'd like to show you our 3D components library. You see, here is our library, 3D components library. This is a QFP and also QFN. SOD, CC, CR, SOP, and so on. We will grab these 3D modules and assemble them on the board. These all components are created by the datasheet. And also we have a tool to convert the step data to the 3D models and then save them to our software. I will show you later. Okay, now we will assign this component assembly process. We will tell the software their SMD part or TH part because this will related to the rule checks. This step that's very important because these all components are created by the datasheet because we can find the graphic information by datasheet. So we think the green color, they are good, so we can pass that. If the color is yellow, we will check whether this component is suitable for the pad. You will confirm that. We see this component looks a little bit smaller than the pad, so that's a problem. So now you can tell the RD, maybe that is the pad design issue. So take a picture and save them to the final report. And also, if you think this is not a problem, just save them. Okay, now we go next step, confirm PCB flow and set the thickness. And then we will do the next part, rule check. We have many rule groups, and I will show you that our rule library later. And now we will check one of them, that the software run the rules. Okay, here is our rule manager. I will tell you something later. All right, okay. This is our standard rule group. You can copy them and save them to your own rule group. You can save them by customer, and also you can create a rule group by product. Maybe we can copy this rule and give them a new name, maybe automotive. Just as Elizabeth mentioned, our rules are very easy to configure. Currently, we have more than 1,500 rule checking rules. So you can modify them and you can receive the rules from your from your supplier and modify them and set to your own knowledge base. Automated right here. Just as it is Beth said, the rules are very easy to configure. For example, this rule is checking AEC distance between capacitor TH. Now I want to check the BGA and maybe SOP distance. So what should I do? Now I copy them and I create a new class, a rule name, maybe C2C check, and paste them right here. This rule is to check AEC and capacitor TH distance. Now I can modify them. I want to check BGA and SOP. And you have your own regulations, and also this recommend value can be set by yourself according to your own regulation. And this color is set by the severity label. Now I want to check BGA, so move this to the left side, BGA, okay. And another component type is SOP. All right, okay, you see, this is a totally new rule. That's very easy to configure. Maybe the distance should be bigger or smaller, maybe 1.5 according to your own regulations. And also you can set the new rule right here, 0.1 to 50. I just would like to show you the rule is very easy to configure, okay? And also, and also there are many rules component, and that's very easy to build. We have a tool, step converter. If you have standard step data, and also sometimes we want to create shields, for example, this one you see, and I convert this 3D modules to our software. Only one click. Okay, I just select this all information and paste them to the component creator tool. That's it. It takes only a few seconds. All right, let's back to the software. Now we're going to check the detect. All right. And we'll see the 3D view, and then we will take a picture for this board and save them to the final report. You see, you can easily to check the component pins and rotate this bottom side. All right, let's take a picture and save them to the final report. And also I will save the 2D view. Bottom side. If you'd like to use our software, we recommend you to have a dual screen. One screen check 2D view, another screen check 3D view. Now let's check it. So this is C2C is checking connector TH clearance. This is the recommended value is 3 millimeters, and the actual value is 1.2. So we will check it and zoom in. All right, it looks a little bit closer. So we take a 3D picture and save them to the final report. And also on 2D view, you can see that and check QFP clearance. This is checking component body to body, connector TH to connector TH. These two connectors are very close. So you decide whether this is a problem. If you think that is a problem, just take a picture and save them to the final report. And we will check other detects. For example, check the IPK port on offset side. So within 2D view, if I am a junior process engineer, maybe I will figure out what is this problem. I need to think. But under the 3D view, we see, oh, we can offset the board. And now we see these two components. Sorry. These two components under the other side of connector TH. So we can take a picture. And this one as well. And report fine pitch SMD component. We all know fine pitch components will cause issues, but in a board there are so many fine pitch components. So how do we check them one by one? If we don't use the tools, we will check it by our eyes. Within this digitalization software, you can digitalize your knowledge in the library, and then we just run the rules, let the software do it, do this repeat job. It will save a lot of time. And check the distance between pH pad and the SMD component. And take a picture. And also check distance of component body to tooling hole and bottom side. And component pin touch solder mask. You see this component, and the 2D view maybe that's a little bit better. You see the component pin touch solder mask it will cause the solderability issue. So we think that's a problem. Then I can take a 2D view picture. Just double click on that. Then the 2D picture will be saved to the final report. And the large hole to the PCB profile. Okay. And take a picture. And also we digitalized the IPC standard to our software. We will check the pad gap or 1206. The recommended value is 47 mils. The actual value that is 0.635 millimeters. Second, I can change the blind. Now it's look better. And so IPC 735Y. So the joint size, for example, this one, offset to another. And also line pattern TH and reflow, so the paste, for example, excessive to the mask window. On 2D view, we can take a picture. And so signal alter, annular ring width of via pad. And that's on 3D view, we can see it very clear. In 2D view, whatever you want, just take a picture for them. Circuit short. The distance of plated hole to trace. You see here's a hole. And pad to pad. And the via without tear job. For example, this one, and many vias doesn't have a tear job. You need to confirm with the RD. And thus we can take a picture on the super screen. You see this one, that's definitely an issue. So we take a 2D picture. And that touch, so the mask will cause solderability issue. And test the point ring size. And the pin, test the point quantity on bottom side and top side. And test the point missing the solder mask window. So if this pad doesn't have a solder mask, it cannot be tested. So we can take a picture. and check the test point hole size. So, and also, if you have any comments on any detect, so you can make your comments. Maybe you can tell them this is a design. Please confirm. Okay, and your comments will be showed in the final report. Okay, let's see the final report. And this is a 3D view and also 2D view. Before we do the entire assembly, so the component mismatch the pad, this part can be reported to your R&D firstly. And as you see here is the precautions and the picture. And we take a picture for and we make comments right here. All right. Now we see this is the final report. With this 3D DFM report, it can improve your company ability and can improve your competitive ability. All right. If you guys have any questions, just tap in our chatting board and then I can answer your questions.
Yes, if you have any questions or challenges you've encountered in your manufacturing process, feel free to ask questions right now.
Yes. Our company value as a technical company, we never stop developing. In the past 2 years, in 2021, we added 63 new rules. And in 2022, we added 78 rules. So we never stop developing. And also our software is customized. If you have any special request and we think that is reasonable, we will help you to develop. And also the rules, we will help you to develop your own rules. All right, gentlemen, if you guys have any questions, tap them in the chatting board, please.
So thank you very much for coming today, and we are very glad to share our solution with you guys, and hopefully we could work more, further together to improve your capability and also utilize your manufacturing process with our solutions. Thank you very much for today, and let's talk later in the email. Thank you, David, as well. Thank you.